Because we're already a touch late, and I understand that we have happy hour after this. Anyway, I thought I'd get us happy by playing a little game, which I call a murder mystery. But first, a little bit about me. I'll spend 60 seconds. My name is Gordon Mackay. I'm Chief Technology Officer of a company called Digital Defense. We do vulnerability management. I've been doing that for many years. I'm a software developer by trade. We also do penetration testing, so I've learned a little bit about that through osmosis, and then security awareness training. So enough about digital defense. This talk isn't really about them, but then again, they paid my trip, and so I thought I would share that. So I was born and raised in Montreal, Canada. I speak English, French, trying to learn some Spanish right now. I graduated from McGill University, if you're familiar with that, in engineering, and started off my career in software development in Brockville, Ontario, for a small company called Northern Telecom. Nortel, you've heard of it. They're out of business now, but they're a telecommunications company. And because I was in telecom, I thought, well, where's all the action going on? Where's all the opportunity? And I quickly realized that was in Dallas, Texas. So I moved my family, my small family and myself to Dallas, and I started working there for a company called Digital Switching Corporation, and doing switching, call processing, those kind of types of software. And then telecom started going downhill around 2000 timeframe, maybe a little bit before then. And then towards 2002, I was on a very large project, and towards 2002, we were going from 300 people to 10. And then anyway, long story short, I was being laid off. I started looking around, and I found this company, Digital Defense, back in November 2002. The vice president at the time, who's now our CEO, said, "Hey, Gordon, why don't you come on board and help us out with this new incarnation of vulnerability management?" And so I did. I learned about it, learned about security, and I learned a lot about vulnerability management, specifically an issue or a challenge within that domain that this talk is based on. So I'm going to share a little bit of research, sort of a mystery, if you will. In my mind, it's a mystery as to why people, it's funny because I've given this talk at different venues before in different formats, and my original format shared sort of a step-by-step, a little bit of background, etc., until finally 3/4 of the way through in the presentation, I shared, here's what the problem is. And then some folks said, that sounds like a murder mystery. Why don't you share that in the form of a murder mystery? Hence, that's what this is. Has anyone played Clue before? The traditional game?
Yes.
Excellent. Okay, so I'm not going to explain the rules, but you have a set of characters. This is the classic, old game set of characters, Mrs. Peacock, Professor Plum, etc. You got a set of weapons, right? The wrench, the rope, the knife, revolver, etc. And then you have a set of rooms. And you have a board where you have rooms laid out, and you're a player, and you move into a different room. And essentially what happens is, at the beginning of the game, you split the cards up into 3 categories: the rooms, the weapons, and the people. You shuffle them up, turn them around, and you take one of those cards from each category, you put it in an envelope. And that envelope is the mystery, right? And so your job as a player is to ultimately come to a point where you can make an accusation that's correct, right? It's, for example, Mrs. White committed the murder in the ballroom with a knife. And if you're correct, you win the game, right? So this is sort of modeled after that. All right, so overview. We're going to go over a crime scene. I'm going to share a use case to set the stage. We're then going to talk a little bit about what I call detective tools, a little bit of background of vulnerability management, scanning methodologies. We'll cover that. And we're going to get into circumstantial evidence. You'll see what I mean by that. Specifically, tracking endpoints or hosts across time is the challenge. We'll talk about Mrs. Scarlett's testimony. We'll also talk about a study that I performed, myself and my team performed, to track endpoint characteristics. You'll see what I mean across time, and how often do they change. It's relevant. And then who done it? This is the point in time where I shared, here's who actually committed the murder. What's the problem? What are the details behind this problem, etc. Victims, consequences, and then finally avoiding future crimes. Now, as I go through this, if you guess it, lift your hand up and I'll call on you. And if you say, hey, Gordon, explain the problem, you don't have to actually say, oh, okay, it's Mrs. Scarlett who committed the murder in such and such place, but just explain, here's what you're talking about, Gordon. Here's what I think this problem is, and if you guess this right, you get recognition, which is pretty good. I don't really have a prize, but anyway. This slide's going to be quick. It's just a slide to share. We're entering a crime scene. Years ago, right? Years ago, most security technologies, or all security technologies, perhaps with the exception of SIM, operated within their own silos, right? So they were solving specific use cases. So vulnerability management's one of those. Identity and access management, data loss prevention, etc. I'm not going to name them all, but essentially they would operate within their own silos, and they wouldn't communicate information to those other silos to solve risk use cases. But as time has evolved, we've evolved in our thinking, right, as people. And also the attackers have been more advanced as time has gone on. So we've been forced to move into and to think about how do we handle more advanced use cases. And so we've started sharing more information within this, what I call an integrated security ecosystem. And so what I've done is I mapped these different characters to the different security technologies, right? Mrs. Scarlett to vulnerability management, Mr. Green to IAM, Colonel Mustard to DLP, etc. One of these technologies is the culprit of this crime that I'm referring to. And what's happening is one of these technologies is sharing information into the security ecosystem in such a way that's often poisonous, it's inaccurate, and we'll talk about why, and it's causing, for example, your security leaders, your CISOs, et cetera, to drink poison. So it's not just the fact that the security use cases is inaccurate due to the poisonous data, but the people who are making decisions based upon this information, unfortunately, they're making right decisions, but based on inaccurate information. Hypothetical risk use case. Now, please don't go out of this room and share, Gordon just released the 0 day, because that's not what I'm doing. I'm sharing a hypothetical risk use case just to set the stage. Now, imagine that we just learned that a new vulnerability has emerged for Apache web server. And that this vulnerability only impacts releases 2.4.0 to 2.4.24, but not the most recently released version of 2.4.25. Does that make sense? What would you do as a security professional to understand, to handle this information and to understand what your risk is in your organization? Well, certainly one of the things you would do is you'd want to query your vulnerability management system to understand where do I have deployed an Apache vulnerable version throughout my enterprise? And you likely could actually query your system, because these vulnerability management scanners, sure, they detect vulnerabilities, but they also detect software and versions, etc. So even though your vulnerability management vendor may not have just emerged with a detection for this issue, you probably can still query your system to understand, hey, where are these vulnerable versions? But likely you'd want to run a recent scan anyway, right? So this diagram is sharing, right, so on the, I guess, from your perspective, right-hand side of the diagram, sharing a network diagram that's showing what are the endpoints, the hosts where Apache is installed at the vulnerable version. So the red dot represents the vulnerable version, the black dots represent hosts that don't have that issue. And you'd be like, aha, I know where my present risks are. This is great. But really, that's not enough. A lot of security professionals would stop there, but there's more information that you can glean. And what I mean by this is, and this is important because it brings in the dimension of time, if you look into the past and ask yourself, well, what if, were there instances where I had this vulnerability on hosts, even though it might not be there today, what if it was there in the past? Is that important? And it could be important because the bad guys and bad girls might have known about this issue, even though you didn't know, and they may have attacked you already, right? So you may have had past instances of vulnerabilities, even though they're not there today, and you may have been compromised in the past. And perhaps your incident response programs didn't detect this. So this is a pretty cool use case, right? And I have other use cases too, but this is a pretty cool use case that shares vulnerability intelligence, where the past is important, if that makes sense. And you can feed these candidates, right? So there's still one candidate that's the same across time, but there's two others that were there in the past that are not there in the present. And you can take that information, feed it into your incident response, and investigate. You know, have I been compromised? Probably not, but it's good information, right? So this is just sharing the value of time, if you will, from a security perspective. So at this point in time of the game, you've concluded Mrs. Scarlet is the guilty party. You don't know the other two components. You don't know the weapon yet. You don't know the rooms, but you know Mrs. Scarlet. Vulnerability management, or I'm sharing this with you. Vulnerability management technologies, and many vendors suffer from this, suffer from a flaw, if you will, or a limitation, where they're feeding information into your security ecosystem in such a way that they're sharing inaccurate data often, or what I refer to as poisonous data. Okay, does that make sense? Okay. So I'm going to get into a little bit of what I call Mrs. Scarlet or vulnerability management weakness or challenge. So I often use this diagram where the challenge is assessing host across time. So if you look at the bottom part of the diagram, and I often fantasize that I'm Doc in the movie, you know, Back to the Future, Marty on the whiteboard, you know, I don't know, anyway. So in the bottom part of the diagram, these are the real world assets, and they may be virtual, but essentially what I'm sharing is you're running specific software using specific OSs on these assets that you can touch. I know it's here, right, from a mental perspective. But, and the top part of the diagram is sharing with you, this is how a vulnerability scanning solution actually perceives these assets at different points in time, right? So the red asset of, you know, for a scan at week 23, I'm just using that as an example, sees it as, in a specific fashion, and its job is to correctly correlate how it sees it at a different point in time in order to satisfy that use case that I just mentioned. So that's a challenge. I think you might be gleaning what I'm sharing as far as the flaw here. So let's talk about vulnerability scanning technologies. I often share it this way. There's more than 3 scanning methodologies, but I'm putting up here 3 different scanning methodologies that pretty much cover the bases, right? I'm not showing passive scanning, if you're familiar with that. But essentially, let's talk about these. So there's agent-based scanning. This is where the vendor comes with, so first of all, vendors provide at least 2, sometimes even 3 of these solutions. And as clients, we'll use a combination of these for various reasons. So let's dive in. Agent-based technology scanning is where you have to deploy, in some form or fashion, a program or an agent onto the endpoints, onto the hosts. And of course, there'll be a centralized scanning management solution that messages these endpoints, likely, to say, hey, I want you to start scanning. And they'll run on the endpoint itself and collect information and determine vulnerabilities, etc. It's got pros and cons. Of course, it's on the endpoint, so it should be very accurate. But the problem is, vendors don't typically emerge with a program for every single type of endpoint out there, right? Windows, of course, they cover, often many Linux systems. And even still, deploying it is cumbersome, right, and costly. So it's great, but often it's used for cases where if it's easy to deploy, great, or for cases where you have, or you know that you have high value assets, right? This is where my data is, so I need something that's more in depth. Remote unauthenticated base scanning. This is a type of scanning, and all vendors offer this, where the scanning engine is it's not on the endpoint; it's remote to that endpoint, right? It's running, and it will send messages. It'll ping sweeps, etc., to try and discover what are the assets that are out there in the ranges. What are the ports that are open? What type of OS are these things? What are its vulnerabilities, etc. Right? And I use the candlestick because the candlestick is like a flashlight, so it lights what it can see. So typically the light is not on the endpoint, if that makes sense. I had to use one of the weapons, and we had so many I didn't have a flashlight. So that's remote unauthenticated base scanning. Very easy to deploy, or easier than the others. In fact, the endpoints don't even need to know, and they don't typically know that they're being scanned, right? And it's quite accurate. The problem is, of course, it doesn't get as much as, say, agent-based or credential-based, which we'll talk in a second, because it's not on the endpoint. But nevertheless, it's going to get you enough information that overwhelms you anyway, to the point where you have to prioritize, what fixes you want to do. And then credential-based scanning is sort of a mix between the two. And that is where you have a scanning engine that's remote, but it will authenticate using credentials that you have to set up to these endpoints that it's scanning. And it would then detect pretty much, almost as much as agent-based will detect, if that makes sense. So it's very accurate, but it does come with overhead, right? You have to administer credentials. You're not going to want those credentials to be long-lived. And then the other point is it doesn't cover all devices, right? Okay, so that's that. So those are the three different vulnerability scanning methodologies. Circumstantial evidence. So before we get into this, most organizations, what they'll do, and we service many organizations, so I know this, what they'll do is they'll set up unauthenticated scanning to sweep their networks by and large, and then on different sections of their network, they'll either use credential-based or agent-based to supplement that. But by and large, unauthenticated remote scanning is the technology that's used, right? Circumstantial evidence. So one question that you may ask is, if you recall the diagram, the previous diagram where I had the assets and the scanning that's happening at different times and how it's related, is how do these vendors actually, what do they do to actually figure out, hey, the asset that I saw at one point in time is the same one as I see at a different one. So I have two different scans. I have hosts that have been discovered in one scan, hosts that have been discovered in another scan. How does the system know? Keep in mind, the scanning methodology that I'm talking about is remote unauthenticated, right? So it's not on the endpoint. It's remote. And so all it could do is, in terms of relating those two and determining, aha, the red asset is really the red asset, is it could only use what it can see. And what is it that it can see in terms of characteristics? Is there anything that it can see that never changes and is permanent? And that's the real question. And a lot of people will say, well, things don't really change that much. I mean, servers, for example. I mean, how often could their IP addresses change? Yeah, maybe a little bit, but probably not that much, so we're probably good. And anyway, so the vendors out there use various different characteristics to match hosts that they see from one point in time to another. They'll use IP address, various types of host name. MAC address is great if they can get it. You can't always get that. I've received a lot of questions on that. We can talk about it. Host type and other types of characteristics. One of the largest vendors out there has an algorithm, and I'm sharing with you, this is how they solve this problem. They use one of the 3 possible characteristics listed here: IP address, DNS hostname, or NetBIOS hostname. So you can go into the vulnerability management and administration as the administrator and specify from such and such range to such and such range, I'm going to use IP address to track that host. But on a different range, maybe I have clients there, right? Maybe I'm in a DHCP range, I'm not going to use IP address. I'll use NetBIOS hosting, etc. So it's flexible in that you can choose which characteristic you want to track on, but it's limited because you only have one characteristic. And so, is that enough? That's the question. Does anyone want to venture a guess in terms of what I'm talking about in terms of this murder mystery challenge, what the problem is? That's okay. Okay, so my team and I performed a study to understand how often do these characteristics that these vendors use to track, how often do they change in IT environments? And you can think, well, maybe in the past, maybe not as much. Nowadays, virtualization and bring your own device, etc. I wonder what that is, right? So we performed this study. We can talk about the logistics of the study. But essentially, we looked at a very large time frame. Keep in mind, we're a cloud-based vulnerability management system, right? So we could actually see all this data in our data center. Even though it may be encrypted and anonymized, we can still glean a lot of information from it. And this is partly how we came up with this study. And what we've determined is across a 3-month time frame, and so what we did is we broke down the study into different device types: client machines, server machines, printers, etc. So I'm just showing you here a cross-section of different device types and showing you servers and client machines. So for server type machines, database servers, web servers, application servers, where you would think that IP address doesn't change that much, or at least maybe, DNS, the characteristics actually change at surprising rates. I was surprised by this. We actually performed this study multiple times just to confirm. For example, IP addresses of servers we found across 3 months change at a rate of 4%. So in other words, if you have 100,000 servers in your organization, 4% of those, or 4,000, would have changed their IP address within 3 months. Could be twice that they change it, but we only counted it, if it changed twice, we counted it once. So that's pretty dramatic. And obviously, in client type machines, you'll notice that their IP address rate is higher, but that's normal, right? Because they may be in DHCP ranges. Great. So what's the takeaway? The takeaway here is endpoints or hosts change. Not all of them, but a certain subset do across time. And if you're looking at these things at different points in time and relying on characteristics to match, but those characteristics are changing, you're going to be wrong. That makes sense, right? So that's what this diagram shows. And I'm mapping the different rooms, like the library and the billiard room, to the different IP addresses. So this is interesting because in this situation, even though I'm using the analogy of Clue, where someone committed the murder in one of these rooms, this problem is even more complex because the murderer commits the murder in different rooms because things change, if that makes sense, right? So whodunit revealed. This is what I'm talking about. We're sharing that in vulnerability, the various vulnerability management vendors out there are using simplistic algorithms to track endpoints across time. This only is really applicable using unauthenticated scanning methodology, because with agent-based, you could actually assign a unique identifier to your agent, and you can use that unique identifier as a tracking mechanism. So agent-based technology or scanning methodology is not prone to this issue, if that makes sense. Credential-based, same thing. As you're doing a credential-based scan, when you're authenticating to a host, you could actually drop something onto it, a unique identifier, so that the next time you come back and do another unauthenticated scan, you'll see, oh yeah, there's an ID there. I'm going to use that as a tracking mechanism. But for unauthenticated, which is the most prevalently used vulnerability scanning technique, that's not the case. And these vendors actually use very limited, checking the time here, very limited algorithms, if you will. One characteristic, in the case of that large vendor I was talking about, even though you have a choice, or maybe 2 or 3, but that's it. So it's sort of like, the analogy I use is if you look at your fingerprint, the vendors are actually using very limited ridges as a pattern matching mechanism to match post across time. And they're going to get it wrong. Not all the time, but enough. So that's sort of my pitch, right? Consequences. So we revealed the murder mystery. But what does it mean to us? 2 things. Asset duplication and asset mismatch. So within the vulnerability management silo, these issues exist, right? So if you just look at vulnerability management, you're going to get into situations where, and we'll go over it, you're going to get into situations where, for example, suppose I do a scan in week 1 and I detect 3 devices, which are these 3 assets. But then suppose somewhere between week 1 and week 2, IT churn has happened and IP addresses have changed. Other characteristics too, but I'm just using IP address as an example. And if your vendor is using limited tracking mechanisms, very possibly they're going to get this mismatched, such that the system believes that that asset up there, that yellow one, is actually the red one, but obviously it's not. So just within your own vulnerability management silo, you're going to get into a situation where the system's communicating to you, but let's make the assumption that the vulnerabilities detected for the red asset are completely orthogonal to those of the yellow one. Nothing in common, just to make it easy. The system's going to declare to you, wow, all of the red vulnerabilities have been fixed. They're gone. What a great job you did. Yeah, you got some new ones from the yellow, but you're still doing a pretty good job. Just solve the yellow ones. So the more you mismatch, the better it looks. But it's not true, right? See, that's the problem. So that's just one example. And then duplication is a situation, I don't have that up here, is a situation where instead of actually mismatching it to a different asset, it says, oh, I've never seen this asset before. I can't match it to anything. Must be a new one. Let's add it to the asset view. So now you actually have a duplicate. We've seen this a lot, and that causes other issues. So the key, so what are the impacts, right? And you can imagine this now. I have a few listed, but sort of at 2 different levels. Within its own silo, you're going to have issues, right? Just as I explained in terms of vulnerabilities declared as being fixed when really they're not, or vulnerabilities having been declared as brand new on your asset when of course they're not. You're gonna start perhaps assigning these vulnerabilities out to your team. And keep in mind, in large enterprises, you don't just have simplistic teams that have, you know, your security team and the owners of the assets in the same teams. Often that's completely different teams. And so often what has happened, and we've seen this in prospects that have come to us, is where you have a situation where if the security professionals are assigning out these vulnerabilities to different teams, those members are actually doing investigation on the vulnerabilities, so they're learning, that's good. I know how to solve it. Let me go find the machine and solve it now, only to determine after quite some time, this isn't even our machine. What were you communicating with? And then they kick it back, and then they finally figure it out. So there's a lot of wasted time, right? That costs money. That's only within vulnerability management. When you talk about sharing information outside and into the security ecosystem, those other security silos are looking at that data and assuming that it's correct. And if it's not correct, you're also wasting time and your security gauges are off. So what's the solution? Don't rely on circumstantial evidence, right? Now, even though traditionally fingerprints considered circumstantial. We're talking about a ridge of a fingerprint as compared to a complete fingerprint. What I mean by this, oh, by the way, I forgot to actually open up the envelope and show you the suspects where you have the scarlet, which represents vulnerability management, unauthenticated vulnerability scanning, which is the candlestick. And I actually put 2 rooms in here as opposed to 1 room because of the room shift, right? So what is the solution? The solution is, look, if we can actually see and view all of these characteristics and all of these vulnerability scanning technologies can, from all the vendors, they can see IP address, they can see MAC address to some extent, they can see and determine OS, they can see what ports are open, they can see what vulnerabilities exist. Why don't we use all of that information? Of course we know it's going to change. But the more information you use, the more it's kind of analogous to a real fingerprint. That is one solution. There are many other solutions, but that's one of them. Are there many vendors out there that use that kind of a solution? Yes. So that's, what I recommend is when you're evaluating vulnerability management systems, and often in the past, what has been done is, hey, let's just run, one scan and compare vendor to vendor to vendor and see what they get and what they miss. But they don't really look at what about across time, and that's extremely important. So obviously, the ideal scan-to-scan post-correlation is to get this right, even though the red asset and the yellow asset, for example, had experienced a change across time. How do you do this? Once again, with fingerprint matching technology, if that makes sense. Murder mystery solved. I think we did this in record time, which is great. Once again, there are use cases out there that you need to consider the time factor. But what does that mean? That means, and also network endpoints change across time. They're not static. So you need something that's intelligent enough to detect that change. But the problem is most vulnerability management solutions are very simplistic in how they solve this problem. And many times when I give this, a lot of people come up to me afterwards and say, wow, I just assumed that it was just working. I never really thought of it, right? But in fact, this is a challenge that plagues pretty much all vulnerability management vendors. And I say that because it also plagues digital defense. But we understood this years ago, and we come up with an algorithm that uses all of those ridges, as I mentioned. Plus, we're able to measure when we're off by comparing ourselves with our authenticated scans, if that makes sense. Use your own endpoint correlation technology if you can, but of course that's not simple. It takes time. There are some tools out there, apparently, that pull in data from vulnerability management systems, and they do have more advanced correlation. So that's another option. I rest my case. Murder mystery solved. Questions? Let's get on to the happy hour. Thank you.